So let's illustrate this. Let's consider example number 1. We're asked to evaluate the integral of x minus 6 over x squared plus x minus 6. Okay. Now you will notice that your integrand, okay, is of the form where the denominator is factorable. And the factors actually are linear factors. The linear factors are x plus 3 times x minus 2, right? Okay. So we have two linear factors here. The first step in evaluating this integral is to find or to express this as sum of partial fractions. Okay. By using the method that we've shown from case 1. Okay. So yeah, this is actually your case 1. It is of that form because your q of x is factorable and the factors are linear. So this can be expressed as sum of two partial fractions where the denominators respectively are x plus 3 times x minus 2. Okay, so what we're going to do is to express this as sum of partial fractions using the method suggested here. Okay, so we have this. First, we express this as factors of linear factors. Okay, and we know that the factors are x plus 3 times x minus 2. And then after that, we're going to write two partial fractions, okay, respectively, as a over x plus 3 and b over x minus 2. Now, don't mind the x minus 6 because that will play its role later. So you will have equals a over x plus 3 plus b over x minus 2. Then the next thing to do there is to combine this now as a single fraction. You put it back, okay, but the numerator will be of this form now, right? Okay, so you combine that as a single fraction. This is your LCD. And then your numerator becomes a times x minus 2 plus b times x plus 3. And you can also express this or simplify this or write this in the form where we can separate those terms with x, okay, in first degree, the first degree term, and then the constant term. No? So we can do that by combining ax and bx, right? So that you have a plus bx, and then combining those constants, negative 2a and 3b. So you have plus 3b. Okay, and take note that this denominator here is equal to that denominator. So that means that in an equation, we can cancel that, right? Okay, therefore, we can equate. The principle is if the two denominators are equal, then the numerators must also be equal, okay? So that means that we obtain this expression, the numerator x minus 6 and the numerator here. This gives rise to two equations actually in A and B. Remember, our objective is to find for A and B so that we can express this as sum of partial fraction, right? Now, look at this. There is a theorem in algebra that says two polynomials are equal if and only if the coefficients of the corresponding terms are also equal. Corresponding terms are those that are of the same degree. So a plus bx here is equal to the same of the same degree with x. So that means that we equate their coefficients. So you have a plus b equals 1 and the constant term with the constant term here, right? So we have this system of equation in A and B variables. Okay, you know how to solve this, right? I'm not going to discuss this in detail, but actually you can determine the value of A and B by elimination. Just multiply this by 2 here, so that A will be eliminated, and then you have 2B plus 3B is 5B. Then this will become 2, right? Then 2 plus negative 6 is negative 4. So you'll have this for the value of B, negative 4 over 5, and for the value of A, 9 over 5. And that means that this rational function can be decomposed, okay, or can be written as the sum of two partial fractions. And the two partial fractions are A over x plus 3 plus B over x minus 2, where your A is 9 over 5 and your B is negative 4 over 5. So therefore, here it is, right? Okay. Your A and your B, which is negative 4 over 5. So let's go back to our problem. We will now replace the integrand, okay, with our new expression here. Okay, so this can be written now as integral of 9 over 5 times x plus 3 minus 4 over 5 times x minus 2 dx. Okay, and let's write this further in simpler form so that we can easily evaluate the integral. We can factor out the 9 over 5 now, and then you have integral of 1 over x plus 3 dx minus 4 over 5 integral of 1 over x minus 2 dx. Okay, you can follow, right? And we're now going to use here the formula for the integral of 1 over u du. I think I've shown you a while ago the formula that will be ln of the absolute value of u. So your u here is x plus 3. The derivative of that, your du is, of course, dx, right? Your u is x minus 2, the du is dx. So no problem. We can evaluate directly now the integral. So this will become 9 over 5 ln of x, absolute value of x plus 3, minus 4 over 5 ln of absolute value of x minus 2, right? Okay, so we have this. Sometimes these two terms with ln can be combined, no? But since we have 4 over 5, 9 over 5 here as their coefficients, that gives rise to a radical form actually, or a fractional exponent here. But I think this is a simpler form.